And for some reason, Facebook always deletes my title and description when I go live. So I don't know. I have to go back and like add it. Yeah, I'm not sure what's going on with that. I think we are live. Yeah, okay. I do need to add the post titles again, or post title again. I'll do that while people kind of filter in here.
All right.
People are used to it. I'm always fiddling with things when we get going here. This is what happens when you're the sound engineer and the interviewer same time. Okay, I think I can edit it later too. So
okay.
But I think it's up and running. Linda, hello. Your Aunt Linda.
Hi, Linda.
Does everything sound okay, Linda? Just making sure.
Can you hear me okay?
And it does look like we are live on YouTube as well. And we're not live on my work YouTube, which I'm always checking because I was streaming on my work YouTube earlier. Okay, we're good. Awesome. Well, we'll let some people kind of filter in here, and in the meantime, for those of you who are maybe watching later, this is I'm Jamon Holmgren, and this is a interview series that I do with people in kind of the Apostolic Lutheran circles, people who grew up in the ALC, who have interesting jobs, interesting life experiences, just kind of interesting stories in general. And I have this big list of people that I've been working through. I had a cancellation, so Nels was kind enough to jump in at short notice. I appreciate that, Nels. Very nice of you to do that. And but yeah, as I go, I will be monitoring chat, so feel free to put in there. If you're watching this live, put in questions, and I'll try to ask Nels any questions about that. And in the meantime, I do have a little bit to go through in terms of some structure of Nels's kind of career path and everything. But I guess to start things off, as usual, I'm going to start with the "Whose Boy Are You" segment. Nels, so who are your parents? Where did you grow up? Kind of what was your background?
So my parents, Orville and Beth Wirkkala. My dad passed away last April. We miss him dearly, but that's part of life, I guess, for all of us. So I grew up in Castle Rock, Washington, which is in Southwest Washington. And siblings, I have 6 siblings, 7 of us total. So Renee is married to Aaron Hendrickson, lives in Stanwood in north of Seattle. And Carl and Donna. Carl lives in Castle Rock still. And then myself, I'm the third one in the age range. And then my sister Karen lives in New Hampshire, married to Chad Gibson. And then sister Lynn, who is married to Emmanuel. They live in South Carolina. And my sister Brenda, married to Chad Amore. They live in Minnesota. And then my brother Jay, who's the youngest, lives in New Hampshire currently. So yeah, that's all of us.
You all are pretty spread out now these days.
Yeah. Jay had been in China and Taiwan.
Wow.
Recently too. So
yeah,
kind of prior to the pandemic. So he really was spreading us out.
Yeah, no kidding.
So, and currently we live in near Maple Valley, which is east of kind of SeaTac area. We're in a small town called Ravensdale, just probably 20 minutes north of the Holmes, John and Helen.
Okay.
So
they're down my aunt and uncle.
North of there. Yep. And my wife Karen and I have 6 kids. Our oldest is 16, Annika, and then Zane, Anders, Lawson, or Evan and Lawson. Emma is our youngest. She's 6. So about 10 years of span there.
Okay. Yep. And we are second cousins. Let's see. You're related to the Candles through, is it your paternal grandmother was a Candle? Am I Am I
Yeah,
misremembering that?
my dad's mom. LC.
Yeah.
Nope.
Yeah.
LC was Candle. Yep.
Yep. And my mom was a Candle, so we are second cousins as
Right.
well. Very cool. And yeah, still letting people kind of stream in here, but so you're now in sort of the Seattle area, SeaTac, kind of south of Seattle.
Yep.
And you grew up obviously here in Washington State, Castle Rock, and but then after growing up, you ended up going to college afterward, and I believe we actually went to the same college years apart, but you went to LCC, Lower Columbia College, right?
Yeah, I went there for a year right after high school.
Yeah.
Yep.
And that's just a community college, but then you continued on after that.
Yeah, so it's definitely not a traditional college path.
Yeah.
Right after high school, I went to LCC. Prior to that, when I was in high school, I kind of thought I wanted to be a doctor. I was going to go to UW, but then kind of got to my senior year and didn't really have those same aspirations. So I just went to college at LCC. I had a sports injury when I was in high school, and so I ended up going through physical therapy, and so I kind of got an interest in that. Kind of going into college. So, stayed local for the first year. Started thinking about, well, if I really want to go to be a physical therapist, I'm going to have to go to a bigger school eventually. So I decided to go to Eastern Washington over in Cheney, so near Spokane.
Okay.
And kind of funny story, but I went in the first day of biology and just sitting there, and like they're talking about cells and mitochondria, and I just remember thinking, I don't want to do this. So I left that class and went and talked to whoever, the advisors, and switched to education, so to be a teacher.
Yeah.
And I lasted another year and a half, and kind of got burned out. And my cousin Neil, who lives down near Castle Rock still, he had moved out to New Hampshire, and I think I probably talked to him a little bit, and like, I just want to do something different. And so I drove cross country with my sister Karen, 48-hour trip, just straight through from Spokane to New Ipswich, New Hampshire, and started working for Somro Enterprises over there as a training and customer service rep.
Yeah. So Somro,
first job there.
So Somro is very familiar to a lot of people, but there's probably some younger people maybe who aren't as familiar with Somro. I remember growing up, they were very prominent within our church circles, but talk about what Somro does, in general.
Well, yeah, so actually my uncles, so Dave and Paul and Jim are my uncles, my mom's brothers. So I started working with them, and in 1985, my uncle Dave kind of scratched on a napkin an idea for a machine that would help with the concrete industry. Yeah. And so that resulted in them inventing this machine called the laser screed. And so it uses laser guided receivers to help set the level of the floor, and then it has an auger that moves the material, and a vibration system that helps to consolidate the material. And it's used mainly on large placement, so wide placement commercial floors. But yeah, I mean, they sold, I believe it was in '99, to Dover Industries at the time, and I'm really not even sure who really owns Somro Enterprises anymore. But a lot of the same people still work there. But back then, I worked with your uncle Ed. He was at Somro for a while.
Ed Holmgren,
closely with Ed Holmgren, and many other people. My cousin Mark Mountain, we worked together for many years.
Yeah, and I'm just going to show this picture that you sent me. This is you on a laser screed.
I was in St. Louis, Missouri, actually.
Okay.
Yeah.
So were you operating it actually like on concrete, or were you like servicing it or something like that?
No, I was operating it. Yep. So
okay.
That was probably early morning. You can still see the subgrade in the background there. So
yeah.
And this was one of our profiling systems that it's not a flat floor, so it would follow a combination of a laser and a sonar sensor on the machine.
Yep. Okay. Interesting. I know that, man, I'd like to do a whole interview about the Somro laser screeds, because that's a whole nother subject. And I know you were part of it. What year was it that you started there?
97.
97. Yeah. Yep. So they were still going pretty real strong then.
Yep.
Yeah. Very cool. So, get back to my notes wherever they went. So obviously, Somro, and but then you went back to school, or you went to school during that time?
Yeah, so I worked at Somro about 4.5 years.
Okay.
And working with the engineers, there's a plant up in Michigan where they were manufactured, and there were a lot of engineers working up there to help design the new ones and work with the old ones.
Yeah.
And so as a customer service rep, I would often kind of test out systems that they wanted us to look at, and I kind of got intrigued in engineering as I was working with them. And it's interesting. I don't really even recall in high school thinking about engineering as a possible career.
Yeah.
I mean, if somebody had really asked me like, oh, what do engineers do? I'd probably have an answer, but I just don't think there's no recollection of that being what I wanted to do. So, but yeah, I kind of got, my interest was piqued with, working with the Somro engineers.
Yeah.
So I kind of like, all right, I'm gonna go to college.
Yeah.
Back to school. And I applied at UMass Lowell, and I was planning to apply at Michigan Tech as well.
Right.
My sister Renee lived up there at the time, and was kind of saying like, oh, that'd be a good place too, and it's a good engineering school. And I got accepted to UMass Lowell, and like, all right, I guess that's where I'm going. And it was local too. So like, it was an hour away. I commuted, but it was within commuting distance. So that's where I ended up going.
Yeah, very, very convenient to where you were living at the time. And I just have a note here that you mentioned that you didn't like to get your hands dirty when you were working at Somro. Tell me more about that.
Well, so it's not quite, that's my note. But so when I was there, my dad taught Carl and I, how to change the oil, how to change brakes, so, vehicle maintenance items. And at one point I kind of made the comment, probably offhand, but like, I don't really like get my hands dirty, maybe when I was trying to change the brakes or something. And so we laughed about that over the years, but it was just ironic that, working for Somro, there were times where I had to change the hydraulic hose under a machine when it was dark. And so I'd come out of there just full of hydraulic oil, I'm totally dirty, just a mess. And then the best part was when, I don't know, fast forward to about 2009 or 10, my son Zane was about 2 or 3 years old, and we lived in Battleground at the time, in a little townhome near Battleground Village. And a ball rolled under our van, and I said, "Hey Zane, go get that, go pick up that ball, go get that ball." And he told me, "I don't like to get my hands dirty." So.
Oh, that's funny. Yeah.
So full circle there.
Well, the getting your hands dirty part, obviously, like, I guess one of the often, I guess, criticisms of engineers is that they don't have the real world. They have like schooling. They have, the math and the computer skills and things like that. But that they haven't actually been out in the field and gotten their hands dirty and that sort of thing. So I assume that your time working for Somro was valuable for that, because you actually got to see that the engineer and apply it.
Yeah, certainly. Yep. And then as an engineer, there are times where you get the opportunity to go witness a test or be a part of that. And so that's always useful. And actually, another Somro story. So I was on the other side of things. I was doing the customer, the hands-on work. And I went up to visit the factory. Periodically we'd go up there, and a group of engineers wanted me to look at one of the machines. And so I would operate these. I would train people how to use them, but also there'd be times I'd operate them. And so I just hopped up there and kind of did my thing. Like, this is what I would do. And I remember them just like gaping, like, "You move it that fast?" Kind of, it's like in the factory, they would never do anything that might damage a brand new machine.
Sure.
But I was like, yeah, this is how you do it.
Yeah.
So,
Yeah.
It's always a good reminder of exactly what you're talking about. Like, if you just focus on all theoretical stuff all the time, you lose sight of some of that stuff. So it's always good to keep those things in mind.
Yeah, absolutely. It's hard to do because it's easy to, like, you've got, a stack of stuff in your inbox that you got to get through. And it's hard to, like, get out of that and be like, oh, I got to go out in the field and see what's really happening out there as an engineer. That's very interesting. So then, you went to University of Massachusetts Lowell, and you also spent some time in Sweden as well, right?
Yeah, after my first year at UMass Lowell, I applied and got accepted, or was able to attend Luleå Technical University in northern Sweden. So just south of the Arctic Circle. And people up there, a lot of people up there have ties with people in the ALC. So it was a natural fit to go there.
Yeah.
But yeah, very interesting. Good time.
Did you learn any Swedish?
Oh yeah. Yeah. I'd kind of learned some before I went, but then kind of getting immersed. I was pretty well fluent, but it's been years now. So I've forgotten a lot, or it's become less natural at this point. But
that's pretty cool. I didn't know that that you'd learned it. Very cool. And then obviously you went through school and graduated. Is there some licensing as well that you had to go through, or you just get a degree and you're good to go for engineering?
Yeah.
For the type of engineering you do.
Yeah. So for mechanical engineering, that was my degree. There was the opportunity to apply for a professional engineer license.
Right.
But, some people that I went to school with did that. I didn't. I finished my bachelor's in December of 2004, and then just directly went into a master's program. And I worked as a research assistant there at UMass Lowell, and then did that for about a year. And then our daughter was due in December, so I needed to find a job.
Yeah. So what made you decide to go for the master's and go beyond the bachelor's degree?
Just the opportunity. I was working with a professor, and he had good, I had an opportunity to work while I was doing it. So that was good, and kind of double up on the educational aspect of that. So. Right.
Yeah. Okay. Yeah, that makes sense. And then that may open up some other opportunities when, later. So then after, or at that point, then what was your first engineering job that you got out of school?
So it was at Raytheon. It was called Integrated Defense Systems at the time, in Tewksbury, Massachusetts. And so I kind of started there and worked there for about 3 years, doing structural analysis of mainly shelters. Like, you picture a truck with a kind of a box on the back, and inside there you might have soldiers that are monitoring the battlefield with computers and lots of equipment inside there. So we would we'd kind of have to look at, when this truck is driving down the road, can all the equipment handle the vibration and the shock events that are going on as it's moving on these rough terrain. So a lot of analysis that is kind of where I started my career there.
So the vibration and shock thing is your specialty, and was that like the central point of your master's, or like how did you get up to speed on that?
Yeah, the master's was primarily focused on structural dynamics. So vibration.
That's what they call that. Okay, yeah.
Yep. And so, I mean, fast forward a little bit, but a couple of my jobs later on really didn't allow me, or they just didn't have that kind of environment that I could kind of hone my craft in shock vibration. So I earned a master's degree in that kind of field, but most of my career has not been. I haven't spent a lot of time with it in my career, so kind of it is what it is at this point. I'm not regretting anything, but anyway, just some of the other jobs I had didn't quite focus on it as much. So I guess my point is that my experience level in that isn't as much as maybe I would have thought it would have been.
Sure.
But.
Yeah. I think that's a common theme for a lot of engineers. It's kind of rare that you, for sure, like totally dialed into exactly what you trained for.
Right.
Just, circumstances, life, what you're interested in, things like that.
Yeah. Where you want to live.
Yeah, for sure. Yeah. And then I remember, I think, boy, it's been a long time since we've chatted, actually. And the last time we chatted, you were working at Lifeport, I think, at the time.
Okay. Yeah.
So that was a while ago. And Lifeport had something to do with helicopters. That's all I know.
Yeah. So I guess it was 2008.
Okay.
We kind of wanted to move to the West Coast.
Yep.
We were living on the East Coast, wanted to move back to the West Coast. And my wife had gone to school in Seattle at Bastyr University. So she was familiar with the area too. So found a job at Lifeport. It's in Woodland. They do primarily air medical products. So if somebody needs to be medevac, they
Yeah.
They have a system that has a stretcher and kind of life support systems, air and suction and those kinds of things. And so I worked as a structural analyst for Lifeport in Woodland for, I guess it was a little over 3 years. Tom Matson, who I worked with him.
From Hawkinson, yeah.
I think he's still there.
Okay. Yep.
But yeah, we worked together there for a while too.
Yeah. Yeah. And I mean, what was that like? Was that you enjoy that experience as well?
Yeah, it was good. There was so at Raytheon I did a lot of software-based analysis where I used a computer program to do a lot of the analysis. But when I went to Lifeport, it's under the auspices or governed by the Federal Aviation Administration, or the FAA. So they have a lot of more stringent rules on how you do your analysis, what methods are acceptable, and so I had to learn or improve my skills in more what are called classical analysis or hand calculations. So that was a pretty good opportunity there to, we could augment it or supplement it a little bit with the computers.
Yeah.
And when I say computer, I mean, it's called finite element software. So it's a computer program that will help you do the analysis and automates a lot of it.
What do you mean by hand analysis? Did I mishear you on that? You were doing the calculations. Obviously, you're using computer to some degree there, but
we're writing reports, but you're actually, you're taking like writing out equations
on paper.
Yeah, well,
really?
You can do it on paper. The final product is on a computer. It's
a
Word document or Excel spreadsheet or something. But yeah, it's a lot of just classical hand calculations that basically show whether the stress is acceptable or not for the given environment.
Yeah, that's interesting. And just for people who don't know, when you're doing this sort of structural analysis stuff, what are you measuring? Like what I mean, just in layman's terms, explain like I'm five. Like what exactly are you doing?
So let's say you have a beam that you want to stand on the diving. Let's say a diving board. Let's make it out of aluminum, just solid aluminum, just to keep it simple. But so it's held at one end, and you're going to stand on the tip, and you want to know that it's not going to break when you stand on the tip. So we would say, okay, you weigh 142 pounds. I'm sure that's right in the ballpark there.
Right. Yeah, sure.
You stand on the end, just like me.
Yeah.
You stand on the end, and I apply 142 pounds, and I want to make sure that the stress level in that aluminum beam doesn't exceed what it can take. And so usually you can either get published data that tells you how strong this particular aluminum is, or you can do a test to say, okay, if I put so much force into this aluminum piece, it will break at a certain stress level. And so that's essentially what it is. There's also strain, which is kind of the measurement of how much material stretches as you pull on it. And that's really a more accurate way of evaluating when something will actually fail.
Yeah.
We also consider, when does something start to kind of stretch and not go back to where it started from? Like a paper clip.
Yeah.
You think if you bend a paper clip, you start to bend it, and it's what we refer to as plastically deformed.
Sure.
And so at some point you bend it enough and it just breaks. But if you just move it just enough and it kind of springs back to its original position, then you haven't ever really plastically deformed it. So so simple examples of what we're looking for.
I just take a little sideline here. I listened to a podcast recently. Dan Carlin, Hardcore History, he's got podcasts, and one of his side podcasts, he did just a discussion with Elon Musk, who's also done a lot of engineering, and they were talking about in World War II how the German engineers had a lot of problems because the materials that they were getting were not as pure, not as there were a lot of more impurities. So they'd have to beef up things that more than they would normally have to, otherwise they just break. Which then added weight, which I'm sure we're gonna be talking more about that when we get to the rocket part of your career. Which added weight, which meant that then they had to add more power, which added more stress to it, which meant that they had to add, beef it up again. It was just a bad cycle because the materials were not consistent. And so I'm sure that's something you have to think about too, in terms of like, are you getting good materials or are you dealing with kind of substandard materials, you know?
Yeah, for sure. I mean, most bigger companies, aerospace companies, have their own quality control departments. That's what they're doing all the time, is they're suppliers of materials give them these certificates of compliance verifying that the material is at least this strong, you know, it's made of this composition of different elements and materials that go into it. So yeah, for sure.
And you don't want to over engineer. You don't want to make it so that it's like too big, heavy, whatever. You want to get, you know, reasonable margin of error, but not like too beefed up, basically.
Right.
That makes sense. So LifePort then, and then you also after LifePort, then you worked for Greenpoint Technologies. And what was that all about?
Yeah, so I was at LifePort, and it seemed like there was some uncertainty with LifePort. This was in 2011. So I learned of an opportunity in Kirkland, Washington, at Greenpoint Technologies, and they do VIP aircraft. So they basically take a 747 or a 787 that some really rich person has purchased, and then now they want a custom interior put into it. So that's what Greenpoint does. They design and engineer the custom interior, and then get it all installed. So similar role there. I was a stress engineer / structural analyst, and just analyzing the designs, make sure that they're strong enough to survive the airplane modes.
Right. Yep. By the way, your brother Jay piped up and said, "Poor Werner von Braun." So he, of course, was a rocket scientist, dealing with the stuff during World War II. My cousin Thaddeus says interesting. So obviously, like, you weren't necessarily designing the planes themselves, but there were modifications, the interiors and things like that, because they all have to be designed too. You can't just, you know, slap in a something designed for a car or whatever.
Right.
Yeah, that makes sense. So the thing that I thought was really, I mean, a lot of the stuff you've done is interesting, very much so, but the thing that I thought was very kind of unusual, I guess, is that where you work now is Blue Origin, which is owned by, or at least founded by, Jeff Bezos. I don't know if he actually like owns it still or what. Maybe he does.
Yeah, he does.
He does. Okay. Yeah. And it's like rockets. It's going to space. It's I think there's some other stuff involved as well. But tell me about, first off, why you decided to apply there, and what that, you know, the interview process was like, and, you know, how you got hired on there.
Yeah, so I don't remember the year, but I started in 2018 there. But at least a year, maybe 2 years prior, a friend of mine who was recruiting for them, our daughters played soccer together, and one day we were going somewhere, and he's like, "Hey, you should apply at Blue Origin." And I'm like, space, I don't really care.
Yeah,
I don't care about that. So it just kind of, I didn't think anything about it. Then maybe fast forward a year or two, and a colleague at Greenpoint was like, "Hey, come look at these jobs." I'm like, okay. So I went over, and it was Blue Origin, and they were looking for people to work with shock and vibration. Like,
wow.
Because Greenpoint, we weren't really doing any of that. I mean, it was like what's called static load. So just here's an acceleration, or here's an applied load. You got to analyze to that. And so it's a little more mundane than shock and vibration. So I applied, and I got an interview. And actually, my friend that initially had mentioned I should try it, he was a recruiter, so he helped me get the interview.
Yeah.
So I went in and had the interview. You give an hour presentation on kind of what you've done, and then you get with 3, 4, or 5 people go back to back. So it's like a 3-4 hour process by the time you get done. And so these are all, I can tell they're all pretty sharp people that were interviewing me. And one guy in particular just grilled me for 30 minutes straight. I mean, I didn't even have a chance to ask any questions of him.
Wow. Yeah.
And it was just one after another, probably in 30 minutes, like 30 questions, like me trying to give answers and not having the answers all the time.
Yeah.
So I got a call today. Now we're just looking for more experience for
Yeah.
this particular role, and so I didn't get the job.
Yeah.
And then about 9 months later, I got a call saying, "Hey, we got someone interested. See if you want to come interview for a job at Blue Origin." It's like, oh, yeah, who's this person? Well, it turned out to be the master griller. So I was like, really? Wow, that's, you know, I kind of just assumed that I didn't pass his test.
Sure. Yeah.
So anyway, I talked to him on the phone.
Mm-hmm.
He was kind of describing what their group does. So it's a different position now.
Mm-hmm.
And then they called me in for another round of interviews. This one was a little toned down. So I still did the group presentation, but then I only might have had two separate interviews. They kind of grouped up into one or two or three people in each group.
Yeah.
So it was a little shorter. So that was okay. So then they sent me an offer, and so I accepted that position.
Yeah.
So that was pretty difficult interview process. I found, and I don't envy anyone that has to go through it, but kind of depends on what you're going into also.
Yeah. So you got a chance to maybe do more of, like you said, the stuff that you had been trained to do. And there is something kind of cool about space. I mean, you got to admit, you know, there's something cool about sending stuff out of the atmosphere.
Right.
So, and by the way, I just want to note to people who are listening, feel free to put comments in. I'll keep an eye out, or comments or questions if you have any. Happy to ask Nels. So aerospace and space are kind of the, you know, similar and they're related, and I'm sure that there's a lot of things that translate over between the two. But did you notice any differences, like when you went to Blue Origin compared to where you'd worked before, in terms of just the vibe, I guess?
Yeah, as far as what the actual work I did, so Greenpoint and Lightsport, the environments are just kind of room temperature, but with rockets you have very, very hot temperatures, like engines, where you're dealing with engines, those are very hot, you know, thousands of degrees Fahrenheit. But you also have very cold temperatures, so you have cryogenic fluids that are involved with fueling the rocket. So something I hadn't really had to deal with, hadn't had to think about very much previously in my career. So that was one of the things I noticed most. But it was just another level of complexity when it came to doing my job.
Yeah, absolutely. And I guess it depends on how you look at it. In some ways, the stakes are higher, but at the same time, you were dealing with, you know, if you're talking about medevac and things like that, it's the stakes are already pretty high, so you got to make sure you get it right.
Right.
But yeah. So has your job changed at Blue Origin, or are you still doing kind of the same thing that you started with?
I'm in the same group. We're kind of we're in the central engineering, core engineering group, where we help to develop methods and tools for the whole company. So that part's been the same, but we've also been tasked more to try to help individual groups that need more analysis support. So recently I've been working on fluid systems, doing analysis of fluid systems, which is not something I had done before. So, you know, I have to deal with pressure, the temperatures of the fluid, the temperature of the environment around it, and then also if there's any kind of accelerations that are trying to move these tubes around, all that stuff is all combined and trying to figure out if it's going to be okay or not.
Yeah. And like what? So Blue Origin makes rockets. We actually have a video that I do want to show at some point here. Actually, I'll show the images first. But it's not. Is it primarily the rockets, or is there more to the company than that?
Yeah, the best way to probably describe it is the vision of Bezos is millions of people living and working in space.
Yep.
So currently we're working on a couple rockets and a few other things, but long-term vision is to support any contribute to people being able to work in space, whether it's like a International Space Station type of thing, or travel between meteors or planets, whatever you can think of it. And it's all like generations away. It's not like anyone expects it to happen like in our lifetime necessarily.
Yeah.
So it's just kind of another way to think of it is we're building a road to space. We're trying to make it more affordable for rockets to launch and land, which is reusability, where we can launch New Shepard and it can land and we can reuse that same vehicle, instead of where a lot of the boosters are generally, they either get ditched into the ocean and maybe recovered or maybe not. But so that's a big part of the cost, driving the cost down, is reusability.
Yeah, and you sent me a couple photos here. If you have other photos that I missed, I can grab those as well. But that, what are we looking at here? So this
is the New Shepard rocket. It's the propulsion module, or the booster, different terminology for it. But this is it landing in West Texas. There's a launch site down in West Texas near Van Horn, Texas, and the engine that takes off is the same engine that relights on landing and just kind of slowly allows it to set down on the pad.
Yeah. Yeah, that's amazing.
Yeah, you can see at the top, those are called drag brakes, those little wings that are at the top. So those actually deploy further up as it's descending. Okay. And those deploy and slow it down so that the engine doesn't have to do all the work.
Right. Okay. Yep. Just sort of speed brakes up there, kind of catching the air. That makes sense. And then the rocket itself then takes over to slow it down. And this is actually a picture of you.
Yyep. So that's in our Florida facility, and that's with a vehicle that has flown. So
yeah, so it's a little charred here.
Yeah. It's a lot bigger than it looks in that previous picture.
Absolutely. Like you look at this here and you're not sure of the size, but you can see Nels standing next to it. And that's pretty cool. Let's see here. Linda asks, how much math is involved?
All of it.
All of the math.
Yeah, pretty much. Yeah, I mean, there's a lot.
A lot of math. Yeah. Don't go into this unless you enjoy math to some degree, at least.
Right.
Arvo Ornama says he is tuning in late, but better than not showing up at all. My brother Denton asks, what are the biggest balancing issues or challenge for rocket components? Is it the managing of the weight of materials or the extreme conditions they'll be under?
That's a good question. It's kind of both. You have to obviously have enough material to be strong enough, but yeah. I mean, the temperatures are very challenging. They make it sometimes you'll have components that are very, very cold fluid. Yeah. But also getting heated by, it can be as the rocket flies, as it ascends, the drag forces of the air really heat up the external surface. So you've got to be able to manage that heat and dissipate it somehow, and manage those force fights with the different temperatures.
And once you get into space, if it's a space going rocket, then you've got a whole another set of challenges, because you have to get there's the incredible coldness of space, but also you still have to get rid of the heat, and that's difficult in space. There's all these things. I know. Steve,
and then also the pressure too. So when you're we don't have a good picture of the capsule here, but that's what the people who have been launched above the Kármán line, that's what they're in. And it's just like an airplane. You've got to have it pressurized so that they can survive. But as you get higher and the pressure outside of the vehicle is almost zero, then your pressure load is a lot. That differential is a lot higher. So
Steve Anderson asks, does he work on new technologies, or does he use existing technology on new projects? Maybe that leads to new technical discoveries.
Yeah, I probably won't say I work with a lot of new technologies. It's a lot of tried and true principles that we're using to do the structural analysis but there's certainly within Blue Origin, there are a lot of people working on developing new technology.
Yeah. There's a lot of technology that has to be made because nobody's really done this other than, I guess, SpaceX is kind of your big competitor out there that does the vertical rocket landings as well. But this is kind of a new race, more or less.
Yeah. Right.
Yeah.
I mean, space travel has been around for, I don't know, 60, 70 years.
Yeah.
It's been around for a while, kind of the space race of the 60s, but yeah, it's kind of a new realm where commercial companies are trying to help progress it maybe a little bit faster and more efficiently.
Yeah. So I want to watch, there's actually a couple of videos that you sent over. Should we watch the second one you sent me or the first one you sent me first?
Let's go with the second one first, or the one in the document first, and I'll set it up a little bit.
Okay, yeah, let me do that real quick. Let me get my stuff here. The one you posted in the document. Okay, I have that one up, and I will share my screen. I have to share with sound as well, but I'll let you set that up here in just a second.
Yeah, so this video is available on YouTube.
Wait, hold on. My bad. I did it wrong. Okay, I think I got it now. All right, go for it.
So this video is available on YouTube. It's a minute and a half long. You can go watch it. Again, if it might come through better rather than stream, but basically this is the first time that Blue Origin was trying to land the rocket. And so anyway, I mean, the video speaks for itself, but I guess I watched this after I started at Blue. I hadn't seen it beforehand. And I don't know, it just really intrigued me or excited me even more so than I already was about, contributing to something like this. So this happened in 2015. I started in 2018. So this was, 3 years prior to me starting at Blue. But a lot of the people that still work there are I can spot them in the video. So anyway, it's pretty exciting.
Yeah, and this is the culmination of a lot of work. I'm gonna go ahead and play that.
Exactly. Yeah, go ahead.
Estimate 30 seconds to engine start. $25,000 feet. Drag brakes are open. $13,000 feet AGL. Estimate 10 seconds to engine start. Engine start, we have thrust. 2,000 feet. 1,000 feet. 500 feet. Gear coming out. 150 feet. Negative 7 feet per second. Gear deployed. 70 feet. 50 feet. Velocity steady. Touchdown.
That is pretty cool. So obviously, did they have crashes before that? Like rockets that didn't make it? I assume they did.
There might have been some.
Yeah. So they were very happy that it worked. That's
pretty awesome. I myself just imagining if I had been doing some of those calculations, okay, I think this is going to happen right here, and then it actually happened. That would be pretty exciting.
That is so cool. Do you want to watch the other one too right now? We can.
Let's wait maybe till the end. See if
sure. We'll
more time.
Absolutely. Yeah, we should have plenty of time for that. Awesome. I mean, I just think that's so cool. It's one of those things that something about your industry compared to mine, software. There's not really, for software, there's just not really that moment. There's a lot of okay, we're going live to 1% of the people. Let's hope we got a bunch of crashes, let's fix it before we go to 2%. type of thing. But it's not, it's just a different cycle, and you never really get that like satisfying, like we did it moment, but that's pretty cool. That's pretty cool. So have you been involved in some launches since
not been not like I haven't been on site at all
Yeah.
for any launches.
Where do they launch from?
New Shepard is in West Texas.
Oh, okay.
So there's Blue Origin bought a ranch, kind of called a corn ranch down there years ago, and have just been kind of developing it for rocket launches.
Yeah, absolutely. It's
not something you can send a larger rocket from. It has to be
right.
We have to know where it's going to land, or if something goes wrong, where it could land, and got to stay within the property. Yeah,
absolutely. So let's see here. Looking for my notes here. Has Blue Origin been a good company to work for? I've heard kind of like Amazon, for example, which Jeff Bezos, he's obviously the founder of it as well. And there's kind of mixed reviews about how the work environment, things like that, even for engineers. But how's it been to work there?
Yeah, I mean, there's been public stuff that comes out about Blue Origin too, but I've never really seen any of that. I mean, the people I've worked with are professional and treat people fine. So it's been fine for me. And it's kind of been my experience with all the companies I've been at. You kind of get in a position or in a group, and it can go a lot of ways depending on the personalities that you're working with. But it's been good for me.
They're not making you work 14 hours a day, 7 days a week. No. You probably don't want to do that.
I've been doing that.
You probably don't want to do that with rocket engineers. Like that could lead to problems.
I mean, there are some companies that do forward around that kind of work environment, I guess. But fortunately, Blue's not one of those. Yeah.
And like you said, this is like a generational thing. You're kind of setting things up for a very long haul, but there's like milestones along the way, right? Like there's things that you can kind of look at as like, we're making progress.
Right.
Yeah.
Like New Shepard is kind of people look at it like it's space tourism, and that's all it is, but it's really us working, with the systems, but getting a better understanding of how all the systems do.
I think I lost you a little bit here.
Oh,
sorry.
Am I back?
You're back now. Yep.
Okay. Yeah, I'm getting practice working with the systems and making sure everything that goes into a launch is obviously a complex system. So it's kind of part of that training ground for making space travel more affordable. Yeah, and not necessarily affordable for you and me, but just that companies can afford to send stuff up, or they can get travel.
Absolutely. And I've thought about this too, like the idea of like flying to space. Now, if you can have rockets that are reusable, easily reusable is the goal. It's like commercial jet lands, and you don't have to like clean the whole thing. You just clean the seats and refuel it and you head out again. It's not that easy, but it's pretty cool. It's pretty routine, I guess, is the big thing. But then that brings costs down like big time. And then people can just be like, yeah, I'd like to go to space, and they can do it. Like right now, if you're like, I want to go to space, unless you have billions of dollars, it's going to be, and even if you do, like, it's going to be tough.
Right. Yeah. I mean, I don't know how much you followed any of our launches, but been some pretty exciting stuff, I guess, from just people that have gone up, obviously, well, no, I guess I shouldn't say obviously, because people may not have heard, but on the first flight, Jeff Bezos went up with his brother and a couple other people. Captain Kirk from Star Trek, William Shatner, went up in one of the launches.
I heard about that. Yep.
But I think the one I'm most excited about is one of the Dude Perfect founders is going on the next
one of the
flight.
Dude Perfect guys. No kidding. YouTubers.
Yeah.
My kids love them. I did not know that.
Yeah.
That's pretty cool. So I'm sure there'll be a video about that at some point.
Yeah. Be on lookout for that. I mean, anything I'm sharing now, I don't share anything that hasn't been
Sure.
on Twitter or
Yeah.
somewhere like that.
Yeah.
So that's our general policy. We're not giving out information that isn't public already.
Absolutely. Steve says the successes are dramatic, probably because a failure can also be quite dramatic. I mean, when you're sending people, a failure can be very. Actually, this is a question. Is there any sort of ejection seat or anything on these things, or do they have to work? Like, have to work?
Well, so a New Shepard, there is basically two separate. There's a capsule, which is where the people are, and that's totally separate from the booster or the propulsion module.
Yeah.
And so in the capsule, there's actually a separate rocket motor.
Okay.
So if there's something that's detected that's going to be a problem or could be a problem, it will eject. It's basically an ejection of the whole crew capsule from the propulsion module.
And then like parachutes or
the capsule is equipped with parachutes.
So it has parachutes. Okay. Yeah. And then
so the idea is the whole capsule, everything escapes from the other part of the vehicle.
Yeah.
So
Makes
that's
sense.
the ejection.
Yeah.
But there's no ejection from the capsule. Actually, I don't remember where I saw it. It might have been like some documentary about maybe the space shuttle program or some program, NASA program, where they were trying to get ejection seats out of a spacecraft, and they were not very successful.
Oh, okay.
No, they never tested it with people, but it was test dummies didn't fare very well.
Have you had things where like your management's like, hey, look into this thing, and then I mean, I don't know how public you can be about it, but like look into something, and then at the end of the day they're like, yeah, it's not viable, shut it down?
I don't think I've been involved with something like that, but I'm sure I mean, every launch is just so complex that if you've ever watched a launch, whether it's NASA or whatever, there's always holds. There's almost invariably, almost every time, there's going to be a hold, and usually it's just maybe it's a sensor or something that's giving a reading, and they're like, okay, let's verify that it's not a problem before we move on.
Right.
But yeah, like we discussed, I haven't been involved with launch day activities at all.
Yeah. My brother Denton says, is there another challenge that if solved would be as impactful as reusable rockets? That's a good question.
Yeah, I'm not sure how to answer that one.
Yeah.
I'm sure there are plenty of challenges, but I'm not thinking of one right now. But definitely ability is a big one. I mean, just if you have higher energy fuels, maybe.
True.
I'll get something that's higher energy. The whole issue is you're going vertical with the rocket, and every pound of mass that you put on the vehicle, you need that much more fuel.
What fuel do these rockets use?
There's like helium and oxygen, lots of different
oh wow
systems. Kerosene, liquid nitrogen, it's liquid natural gas.
Okay, so it's not just like one thing is the most common. There's many different types.
Right. Yeah. And I'm not a fuel expert at all. So.
Yeah.
I'm throwing out the names I've heard.
Yeah.
And there's probably a small handful that are like, these are the fuels, and then there's always an oxidizer, so they have to work together to fuel the rocket. But
that makes sense.
I'll leave that for the rocket scientists.
Yeah. Laura George Conover says, I can't do all the math, so I became a pilot instead. I had the opportunity to meet Wally Funk, who was on the first flight.
Yeah.
She's amazing. What a cool job you have. So Wally Funk she was an astronaut, and she flew also on the New Shepard, I think, right? So
the first flight with Bezos. Yeah.
Okay. Yeah, that's cool. She was an amazing woman. Amazing. My Aunt Betty Lampinen says, would you want to go into space? The hesitation says something.
Prior to starting at Blue, it probably would have been flat no, not interested. But once you see the systems and see how safety is valued, give it more thought than flat no. But at my age, young family, not my first priority.
It's still a risk at this point. There's there hasn't been like a catastrophic failure that's resulted in in terms of private space programs, but I'm sure one's coming at some point. Something's going to go wrong. It happened for the public ones too, and so and they put billions into those. So absolutely,
it was actually really I would say ironic and tragic, but one of the people that went up on one of our flights died in a plane crash like within a month of flying on New Shepard.
No kidding.
He was a private pilot, and he was flying somewhere and crashed in a lake or something. It was wow, that's
yeah. There's risks to a lot of those things. I know my brother Lucas, one of his former bosses, just passed away like 3 weeks ago or something in a private aircraft. He was flying his own plane and he ended up crashing, which he had an emergency of some sort and couldn't pull it off.
Wow.
So those things there's risks involved with that for sure. Steve is wondering if you have to be on guard against espionage, especially from foreign entities. And I'll add on myself also, there's also kind of corporate espionage between competing companies and stuff. Is that something you have to kind of think about?
For sure, yeah. I mean, every communication that we have with an external vendor, they have to be in our system with all kinds of NDAs in place, and they have to be vetted for those aspects. We can't just directly communicate with a non-U.S. citizen, even if they're in the U.S. They have to be U.S. person. So there's plenty of that you have to be aware of.
Yeah, that's interesting. Thomas Wirkkala says hi, guys.
Hi, Tom.
Is that your uncle?
My uncle, yeah.
Okay, yeah, I thought so. Cool. Any other questions? Please fire them over. Let's see here. So right now is the current goal of Blue Origin primarily just like scaling up, getting more rockets, or are there still some things that you all need to solve with like prototypes and stuff before you can start sending people to space like very regularly?
I mean, we're kind of doing both, I guess. At the same time, we're developing New Glenn, which is a much larger rocket, and that will launch out of the Cape Canaveral in Florida.
Oh, okay.
So
I hadn't heard of that.
Yeah, still in development, but it's a big program, and then we're continuing to kind of improve and work with the smaller vehicles, New Shepard, and we have other projects that are going on too. So
would you all like end up selling these rockets to companies to operate, or is it just going to be operated by Blue Origin?
It could happen, I guess. I don't really know. We do sell engines currently. We are developing engines for ULA, United Launch Alliance. So that's kind of another aspect of our business.
Okay, certain like components basically of spacecraft,
right?
So sold to other companies because that kind of makes sense. Like Amazon is famously like modular in how it approaches things. Where we use my company, we use Amazon components for all kinds of stuff. And it's because everything's pretty much available. Anything you see on Amazon.com, you can make your own Amazon.com for a lot more money. But you can make your own using all the same tools that they have.
Yeah, right.
Yeah, that's I guess that makes sense to make it more modular like that. Your brother Jay says, looking at the version, looking at the V1 in 1940 and the New Shepard today, what would be a parallel example of advancement in rocketry? I'm not totally following the question
sure
there, Jay.
Yeah, I'm not either.
So what I think he's saying is like, what's the if you take the difference between the V1, which I think he means the V2, the V2 rocket that was developed in World War II, and you compare it to the New Shepard, like, is that the difference between a 1940 Ford and a Tesla or something? Like, what's
right.
What's here?
Yeah, I mean, I guess one thing is I don't know the V2 really at all, other than I'm guessing it wasn't autonomous. So that would be one big difference. I mean, it may be a little bit of guidance on it, but it probably just
I think you light it
with the motor and it goes.
You light it and let it go. I think that was it.
I mean, New Shepard flies itself, so
yeah,
it launches and then it lands.
It's all the electronics
without with guidance and navigation systems. Basically, it's not it's not just a dumb rocket or a dumb missile just going. But I mean, there are missiles with guidance on them already nowadays too. So this one just doesn't have a ballistic warhead on top.
Right. Right. Yeah. Is that something that's like kind of a no-go, like not going to do any military applications with this, or is that something that could be?
Yeah, I haven't heard any talk of that, so I kind of assume no. But
I mean, I guess there'd be like, hey, launch the satellite for us or something like that. I'm sure that there's some of that, because it's not just sending people; you can also send cargo and whatnot. Yeah, that makes sense.
Isn't set up for that, but New Glenn would have that capability.
Oh, I see. Okay. Yep, that makes sense. Den says, I've heard scaling manufacturing is one of the hardest parts of rockets just because of the infrastructure involved.
That is a very difficult problem.
Yeah.
So, for example, Cape Canaveral, our facility has to be there. You can't build a rocket the size of New Glenn and ship it from Kent, where our New Shepard rocket's built. But New Shepard's small enough that it can go over the road to get down to Texas.
Oh, okay.
So we couldn't just build everything in Kent and then just ship it anywhere in the world. It's just too large.
Wow. Yeah.
So it has to get basically like a barge on wheels, moves New Glenn from the manufacturing facility to the launch pad.
And I just even thought about this, like Boeing, for example, could make an aircraft in Seattle, and when they're done, they can just fly it to where it's going to go.
Right.
You're not going to do that with a rocket, really. Probably not. Yeah. I guess you technically could. It just seems like probably not. I don't know. That's an interesting thought. Ferrying rockets across the world. Arvo says there are serious objects sailing in the space above. What are the chances of having a collision with one of these? That's a good question.
I haven't kept up on space junk very much. I know there are businesses that are cropping up to try to deal with that, but I think the current vehicle that we're flying is low enough that it's not gonna hit anything, and we can monitor that stuff prior to launch. New Shepard's only like a 10-11 minute launch, but the whole flight time from takeoff to landing is relatively short. So that's relatively easy to control. But
how high does it go?
It's over the Kármán line, so it's like almost 400,000 feet.
Okay, wow, 10 times as high as a commercial jet airliner. Yeah, yeah, that's a ways up there. Yeah, yeah, that's interesting. Vertical landing's interesting because like until SpaceX did it, and then you folks did it, it was like I hadn't even really thought of the idea of landing a rocket. It just didn't like,
right.
You just never think of that, so, but it's a kind of an obvious thing in retrospect, but also something you probably couldn't do without really advanced computers, software, sensors, fine-grained control over your rocket maneuverability and stuff like that. That's really, by the way, are you connected with the people who do any of the software side of things?
Yeah, I mean, they're they're in Blue Origin.
Yeah. So you're,
I don't work closely with them, but
mm-hmm.
Yeah,
because that part is fascinating as well. I know that like like what we do, if we build like an app or something like that, if there's a problem, we fix it. We ship out an update, and people might be annoyed for a little bit, but then that's the worst that comes of it. But when you're talking about writing software for rockets that are going to space, that are carrying people, you better have like multiple redundancies and a lot of testing and a lot of like, it just the bar is just so much higher.
Yeah, I mean, they have what they call hills, hardware and loop simulation centers, where they set the whole system up just in a room and run it, simulate what the signals are into the software and see how it responds, make sure it's not getting hung up on something. So yeah, that's definitely a big part of it.
Yeah.
And then redundancy is important too, to have multiple systems kind of do the same thing.
Right. Yeah. So if something fails, it can drop over to the other one. Jay asks, what is the most difficult part of shock and vibration analysis?
It's all so dynamic, I guess. Yeah, it's kind of a hard question to answer, but the interaction maybe between parts, understanding what's actually happening, and when you have, let's say, for example, you have a joint that's bolt, and then that kind of hold two parts together. The interaction can be very nonlinear depending on how much force you have at the joint. So if you might predict that it's going to see 1,000 pounds, but then once you actually apply the loads and under shock or vibration, that response might change depending on the level of force during that. So I guess my answer is the nonlinearity aspect of those types of excitation.
Yeah. Do you ever get into the car and something's like vibrating or rattling or something? You're like, oh, they didn't design that right.
I just try to hold my hand on it so it doesn't
just like yeah. That's a very advanced engineering concept there. Bang it, hope it like stops.
It's kind of funny because at Somro, the vibration system is basically it's an imbalance in a shaft. It's rotating that causes the vibration. And so I didn't really think about it much while I was working there, but then when I was studying it in college, like, oh,
that's why. Yeah.
That's interesting. That's something you generally don't want. You don't want an imbalance in anything you're using, but in this case, that was what drove all the vibration and was a good thing for the concrete floor.
What would you say has changed the most in your time in this industry, like from when you started to how you do things now?
Actually, maybe one thing, kind of hard to judge which is the most impactful, I guess, but Amazon's AWS systems that allow for really high performance computing. It's probably been one of the bigger thing, and it doesn't have to be Amazon, but any of those data centers that allow you to access their high powered machines and kind of rent them for a certain amount of time. And you can run your simulations a lot faster that way.
I would not have expected you to say that, because that's actually one of the biggest changes in my industry too. The exact same thing, AWS, literally. It like, revolutionized so many things in software. That's fascinating, but it makes sense because a lot of times you would be kind of limited to your local machines, or maybe if you had like some sort of a server farm locally. But now you can farm that out and you can just scale it up. You can just be like, okay, 10's not enough. Okay, let's do 1,000, boom. And you have just tons of computers running it.
And for what I do, it doesn't always help us, because once you have that more capability available, then you can be kind of lazy in how you create your models. So we can create models that are really complex, and sometimes it's appropriate, but there are often times where you probably don't need, something that's 100 gigabyte database to analyze, which is going to require the AWS solution. But you could probably simplify it and make it a lot easier to solve a lot quicker.
Yeah.
With a simpler model that will do just the same. But yeah, it's definitely for Blue Origin, for the kind of work we're doing. It's definitely useful, but at times you can find that it just kind of makes you lazy, and
yeah,
you don't build your models as well as you should, maybe.
It's the same for us as well. There's plenty of things that enables lazy behavior for. Yeah, absolutely. Have you, and this, you may or may not, have any experience with this, but do you see artificial intelligence or machine learning impacting what you do, anytime soon? Have you seen anything kind of coming in terms of, sorry to nerd out, by the way, everybody, but this is stuff that's really interesting to me.
Yeah, my day-to-day job, I haven't really
seen a lot of that. Yeah.
Any of that.
I mean, it's barely landing right now for us, for the software side, but
yeah,
I do see it probably coming at some point, maybe in the next 5 years, that you could run some of your models through machine learning, and it will tell you things you never thought to even ask. Like, you just didn't even think to, like, that this would. It's just simulating everything. So I think that will be it'll be very interesting in the next 5 years. I think it's going to change a lot of industries, including probably what you're doing.
Yeah, probably.
We're already at the point right now with software where I wrote a couple of scripts the other day just for some stuff for streaming stuff, actually, that I do. And the machine, the artificial intelligence wrote the script for me, and I just edited it. That's all I did. I didn't write it. It was just kind of prompting it with English words, and it would write it, and then I would review it and make sure it was what I wanted. And so it's not like it's doing everything for you, but it's like accelerating how it basically makes me twice as fast, because I can just review it and go through. And I can imagine for you, like a lot of your equations and things, you could write out the name of the equation, and it would infer from a lot of the stuff that you kind of have already, the context it already has, just dropping it in there. And then you can use your many years of doing this to look at and say, that's not quite right, or, tweak things.
Yeah, that's good to think about. I'll have to ponder that a little more.
Yeah. That'd be, we should definitely stay in touch about stuff like that. I think that'd be interesting. Gail Max says, I know you've already probably said, but how long have you been doing this? And then she has a follow-up question. What is the craziest thing that's ever happened?
So Blue Origin, I've been there just over 4 years. I started my engineering career in 2006, so 16 years, I guess, for that. Craziest thing. Probably Somro. Somro's probably done more crazy stuff than engineering. Engineering can be relatively mundane at times, just paperwork and crunching numbers. But I had a pour somewhere, and I don't remember even the state I was in, but we had poured one night. It was in the south, so it was hot, and we poured a slab from like midnight to, I don't know, 7 a.m. or something, and then I kind of hung around for part of the day, and then went to a hotel for the night. But we were going to pour again at midnight, and so I was kind of just relaxing in the hotel room, and I woke up 30 in the morning.
You dropped out for a second. What did you say?
Oh, so I was just relaxing in the hotel room, kind of planning to get up at like 11 o'clock to go back to the job. Yeah. And 11 o'clock at night, and it was 3:30 in the morning when I woke up. So I raced to the job site, and everything was going just great. So I went down there to train them how to use the system. And the first day I pretty much ran it most of the time, and the other operator was running it too, but it wasn't really going that great. There was kind of some challenges on the floor. So I was just
you were convinced it was all a disaster.
Oh yeah. It was fine.
Anyway, concrete won't wait. Yeah. No. Yeah. Wow. Yeah.
So I slept in. That's what happened.
Yeah. Totally. No, that's interesting. Somro, that's a whole nother thing, and I feel like there's definitely, I would love to have some folks on who were throughout that ride, because they were just like, from your uncle, like just kind of sketching it out, like where did that idea even come from, and then I've heard some things from my uncle Ed about how the early days went, some of the things that they had to do to kind of iron out issues and things like that, but literally changed the world. It changed the world in very visible ways, like just used everywhere. And the way they used to do things for giant, flat work pours was just so bad compared.
Yeah.
Not even close.
Right.
Yeah, it's not too often that you get to be a part. And you were there, I mean, relatively early. I mean, it was, 10 years into it or whatever.
Yeah, a little more than 10 years.
Yeah. But it's still relatively early when I assume it was still being adopted around the world.
Right. Yeah, there were plenty of people that were getting their first machine.
Yeah.
Companies that have been around for a while.
Yeah. Just to talk a little bit more about that, how did people pour big pours before using a laser screed?
A lot of it was by hand, just with a 2x4 or a metal 2x4. But also they had like truss screeds where they would set up forms that were maybe 20 feet apart, and they would kind of work those screeds along.
Yeah.
It was a lot.
Took a lot of setup and tear down, and
yeah.
Probably wasn't as accurate either.
No. Yeah.
Not even close.
The screeds are much more accurate and level and flat.
Yep. Yeah. That's interesting stuff. Uni Aho West says, I would love to hear the story because Alan was doing concrete before and learned the new way. So her husband, I think, was doing concrete before the screed and had to learn the new way. Yeah. They worked a lot harder. Yeah. I mean, I'll tell you what, concrete people, no matter when they're doing it, they work really hard. That's for sure. But I think it allowed them to do much more with less. Yeah,
definitely saved some labor too. Saved some backs over the years.
Yeah, right. Yeah, I've done just enough screeding, which isn't very much, to know that was not for me. Yeah, very cool. I just have a couple more questions here. Nels, let me pull those up. So what would you say are the best parts of the job for you?
Well, I enjoy math and working with numbers, so that's been obviously what keeps me in the job. But I think I would say one of the best parts is once you have gained some experience, and then you can help other people, mentor other people in how to do the analysis, how to think about problems. That's always enjoyable to have someone come and ask you a question, and then you point them in the right direction, watch them kind of go try to figure it out on their own.
Yep.
Yeah, I'd say that mentorship or the mentoring aspects are enjoyable.
Yeah, and then what isn't so great? What sucks about the job?
Probably just when you're dealing with difficult people. That's probably the more challenging part, where maybe whether you're walking on eggshells because you don't want to cross them, or just dealing directly with them, and they're just not seeing your side of things, and maybe it's me not seeing their side of things too. But just conflict that can be difficult to resolve. Yeah,
absolutely. I think that has been my experience in everything I've ever done. Is you can have the most amazing job in the world, but if you're working with people that are unpleasant, it can make it miserable. And you can work in some pretty rough jobs if you work with some great people, and that that just makes all the difference in the world. And you did send me another video that we can take a look at here. Let me make sure I haven't missed any questions though first. Arvo asked, from the time of Sputnik launch in Russia, Russians have used kerosene-fueled boosters successfully. Why have they taken this way of sending their payloads up into space?
I'm not sure. Not a Russian rocket landing threat.
Probably cheaper, and they can probably get the materials. That's a lot of times what Soviet what drove a lot of the Soviet
Yeah.
stuff was kind of like they couldn't get the exotic materials that we could.
Yeah, but I think kerosene still is used by, it's still it's still chosen at times to fuel rockets, but by other people too. So.
Yeah, sure. Yeah, and it's not just the cost, although that I'm sure is a factor, but yeah, that makes sense. Yeah, very cool. I do want to show this this here. Let's see if I can get it queued up here.
Yeah, so this video is kind of a summary of many of the launches that have happened over the years, and the guy narrating it, he actually flew. He's one of the architects of the New Shepard, and he flew recently on one of the launches.
Okay, cool. Well, let's take a look.
For New Shepard, we've been following an aggressive step-by-step approach from the beginning. The first time we flew New Shepard, we demonstrated every single aspect, re-entry, parachute deployment, and that mission was 100% successful for the capsule. M2 was about rolling in changes and trying it again. This time we stuck the landing, but we needed to show we could do it again. So that was what M3 was. For M4, we pushed the envelope, lighting the engine just seconds before it would impact the ground, and we perfected it at that time. In M5, we intentionally did not deploy one of the main parachutes, and it worked perfectly. We had done a pad escape test that the capsule can launch and escape if there is an accident on the pad. The M6 mission was about testing that at its most stressing condition. We ignited the solid rocket motor in flight and showed that we can recover the capsule safely. For M7, what we introduced was a new capsule design. M8 was just a repeat, and then the third escape test was to show that we could escape in space. So on M9, the capsule lit off its solid rocket motor and landed safely. M9 and M13, we are flying payload missions for customers, giving us even more and more confidence in the capability of the New Shepard system. 13 was a perfect flight, preparing for the M14 mission, another verification and check. This approach led to our first human flight, a completely nominal flight with our first ever human passengers. And for each operational human flight, we will continue to learn and improve our approach to safety.
Okay, that's pretty cool. Yeah. So they went through all kinds of iterations before they first had the first person.
Yep.
Yeah, that's pretty neat. That's pretty cool that you're a part of that, Nels, and I'm glad we got connected up again, so we could chat about this and see what you're up to. It's cool stuff. It's definitely neat. I appreciate you spending the time to chat about it.
Yeah, my pleasure.
Awesome, and thanks everybody for sending in questions as well. And those of you watching later, appreciate it as well. And the next time that I will be, I should have been prepared for this. I'm actually August is going to be a little bit hit and miss for me. I will post in the ALC community group when we have a confirmed interview coming up. We have some interesting stuff coming up, so definitely tune in at that point. There is a YouTube link for this, so if you know someone who's not on Facebook who might want to watch the interview with Nels, you can just send over the YouTube link, and I'll put that in the comments as well. So cool. I think that's pretty much it. I'm going to go ahead and end the live video. Appreciate it.